Hello, my name is Matthew Fisher. This is the Effective Software Engineering video series. So this is the chapter on process. We have broken software engineering into three large pieces: process, programming, and testing. So in this one, we're going to talk about process. So what do we mean by process in software engineering? So there are a bunch of parts to software engineering, programming being one of them, testing being another, but there are many parts. Oftentimes this process from idea to software creation to deployment to eventual retirement of the software is overlooked by software engineers in our field. There is a big focus on some parts of it and very little focus on others. But every piece of it is required, at least in some small measure, for a successful software product. By having an understanding of the process of software creation, as software engineers, we can be much more effective at our jobs. And our job may be upfront stuff, doing requirements. Our job may be as programmers, designers, architects. Throughout the IT industry, there are software engineers. Steps in the process that I've written down here. I'm not going to discuss all of them in this video, but if you want to take a look at some of my notes, you can get up onto the website at www.dynamic-memory.com in the video sections, and then under there, show notes. And I'll have a much more comprehensive layout that I'm going to be able to hit in this video. So the process is related to the software development lifecycle, SDLC as we refer to it in the industry, but I think it's even bigger than that. So for example, I think the very first step of the process is a business case. So we are focusing on industry software rather than on academic software. And in industry, if we don't have a business case for software, then there's no point in doing it. And any engineer that pushes forward with software creation without a fundamental business case behind it is really not doing a service to the company that he or she is working for. So the business case is something that's often left out of the whole process of creation software, and it certainly should not be. Feature selection, requirements, estimations, and refinements. So these pieces, these front-end pieces as they're commonly referred to by programmers, are vital. So again, bringing back the goal to mind, our goal is to produce a piece of software that is successful in the marketplace. And external factors, competition and other factors that are beyond our control will push on that. But if, as an engineering organization, we get the requirements wrong so that we produce a piece of software that is not what the market wants or our specific clients wants, then it's not going to be successful. And our company will end up losing money, perhaps, or time to fix it, customer satisfaction, and we'll, in some way or another, be in a worse position. So getting the front-end portion is very important. And we kind of have a middle portion where there's design, coding, and testing. We're going to hit on this area pretty heavily in some of our other videos. But these are vital, right? This is where the software is actually created or enhanced. And getting that portion correct is, again, required if we're going to have a successful software product. To produce a poor design that does not effectively embody the software, then it doesn't matter if the coding is right or not. If the design's wrong, the product's broken. And coding, of course, is important. Testing is critical. So then there's some back-end stuff that is, often overlooked. Physical topology, right? So if we have a large, complicated software project, let's pick an industry, the telecom industry, right, where a software product may span dozens of hosts, computers that is, or hundreds sometimes, and have a very complicated runtime strategy. The physical topology matters in a very big and complicated way. Some of the smaller stuff, but just as important, the build, packing, packaging, and delivery, particularly with retail software. This has to be done properly. If there is an error in those steps, we can get software out into the field that is not what we intended, or the software that we do get out there won't install properly, and we have a bunch of customer support. So these back-end steps are very important. One that's often overlooked is operations. So there's sort of two broad models of software: the service bureau model, where a company runs software on the behalf of someone else, and this is very common in large-scale industry, finance and telecom, others. And then there's the retail model, where a particular application is running on a personal computer for one person. Certainly the apps that are coming out on mobile devices are bringing the retail software to a new and exciting level. So operating the software is the longest phase in the life of software, and having that software be easy to operate, having it be cheap to operate, which is not necessarily the case in a service bureau model, is very important. And part of that process needs to be thought about long before the software is actually sent out into the runtime environment. Some final back-end pieces that are just as important in the process of software engineering is deciding whether the software is in fact a success in the marketplace. Doing profit modeling, the back-end business stuff of billing for the software, finance for future development and organization there, and even marketing, which is a key aspect of making a piece of software successful in the marketplace, is part of the process of software engineering. So I think that is probably a little bit broader scope than certainly most programmers think about, and other people within the IT industry probably think about. So when we think about process, let's try to think about the whole scope of software as a product in the marketplace. And this is quite a different idea than we see in academia, where software is thought very much as a science-based strategy for the creation of effective algorithms and new languages and all kind of exciting stuff, but pieces that are not always at least applied in industry. So process is big and it's complicated, and for some of those pieces we're going to hit a bit more in some chapters that are coming up soon. Thanks for joining me today. My name is Matthew Fisher. If you want to contact me, certainly feel free. It's Matthew, M-A-T-T-H-E-W, at dynamic-memory.com. And if you'd like some more information about these series of videos or some exciting tools that I have on the site for C++ and Unix shops, certainly get up on our website, www.dynamic-memory.com. Thanks and have a good day. The next chapter in the series is going to be about programming. Before you view that chapter, I'd like you to think about a few things. With regard to software engineering, where does programming fit into the whole model? And within the discipline of programming, how do you apply software engineering principles to your daily job? Or if you're still in college, when you get that first job, how are you going to apply engineering discipline to it? By using some strategies that we lay out here or that you can find in books, you can be a much more effective programmer. So I hope to see you in that next chapter.